Good morning, children. Today we are learning the first lesson in physics, that is motion. Dear children, any object or things in this world either are at rest or in motion. Now, let us understand these concepts one by one. Wherever a body is in a fixed position with respect to a reference point, then we say that body is at state of rest. If we take example of a shop and a driver, when this driver is not driving his two-wheeler, then we can say that he is at rest with respect to the shop. That is, here we have taken shop as a reference point and driver as a body or an object. That means a body is said to be in a state of rest when its position does not change with respect to a reference point. Then, do we say, when do we say that the object or a body is in motion, children? If I take the same example by considering a shop as well as a driver. If this driver drives his two-wheeler forward, then with respect to the shop, the driver has changed his position from this place to the next place. That if I change, then the driver is changing the place from initial position to the final position. That means we can say that the driver is in motion with respect to the shop. That means a body is said to be in motion when its position changes with respect to a reference point. Then we have types of motion. They are linear motion, circulatory motion, oscillatory motion. Now, let us learn one by one. Already you have learned in your previous classes about these types of motion. Let's recap once again. Linear motion is a motion where object or a body is in a straight line path motion. That means I can give the example of a driver and a shop. Wherever the driver changes his position from one place to the another, he is moving in a straight line path. Therefore, it is an example for a linear motion. Then what about the circular motion, children? Circulatory motion is a motion where an object will have a circular path. Wherever the object follows a circular path, then that motion is known as a circulatory motion. Then what will happen to the next types of children? That is a oscillatory motion. So oscillatory motion is nothing but it is a motion which will give a to and fro motion. So that is to and fro means, so here if I take a pendulum bob, if I consider a pendulum bob, then that bob will move from to and fro motion. So this is the mean position of a pendulum bob, and the oscillation of this pendulum bob will give an example for oscillatory motion. Now, in this lesson, we are going to learn about the physical quantities. What do you mean by physical quantities, children? It is a property, that is a physical property of a material that can be measured. You can consider any of the object or a material in this world. If it can be measured, then it is called as a physical quantity. So it can be speed, distance, weight, force, anything. But what about the sound and light, children? Those are not physical quantities because we cannot directly measure them. What we are measuring about the light and sound is just intensity, wavelength. Okay, so therefore light and sound are not physical quantities. Now, we have two types of physical quantities. What are they? Scalar quantity, vector quantity. Scalar quantity, it is a physical quantity having only magnitude but not direction. See here, so in the scalar quantity, so we are mainly concentrating on the magnitude. What do you mean by magnitude? It is a numerical value of that measurement, but not the direction. We are not giving much importance for the direction in which it is the object is moving. So here the example we can take is speed and distance. Similarly, here we have vector quantity. It is a physical quantity having both magnitude as well as the direction. So here examples are velocity, acceleration, displacement, momentum and force. So in vector quantity, what is the thing we have to give more importance is about the direction. Along with the magnitude, we have direction also. So that means wherever the object is moving, so in which direction it is moving, so it is important to mention it. Now, in this chapter, what are the physical quantities we are going to learn? That is, physical quantities we are learning is distance, displacement, speed, velocity, uniform or non-uniform motion, acceleration. Then let's see the distance. The actual path length traveled by an object is called distance. So, we will understand this definition by taking an example. So here I have taken the object A. So say that the object is at position A and I have marked the other three positions also, that is the object B, then C and D. So here let me take this as 0 point, that is a initial position, and 100 as a final position. So the final position changes according to the reference point what we take. Now the first point, that is from 0 to this position, let me take this as the kilometer. So let me write this as kilometer. Then let me take, if the object is at position A, then it travels from position A to position C. Then what is the distance that is being traveled, children? So from this point to next point is 10 kilometer. Again from 10 to 20 is 10 kilometer. Like that, if I count from A to C, I'm going to get the 60 kilometers. So if I start from A to C, so then the length followed is 60 kilometer. Now again that object will move backward. As I've said, in distance travelled, so it is a scalar quantity. So therefore, we are not mentioning the direction. Again, it will move back from C to B. So therefore, the object is now coming back from C to B. Now the object is at B. Earlier it was at A. Now the object is at B. What is the distance travelled? Actual distance travelled. So first it has travelled from A to C. So what is the distance, children? It is 60 kilometers. Then after that, again it has travelled from C to B. Then what is the distance in the second position? It is 20 kilometers. So therefore, altogether you have to add 60 plus 20. It will be 80 kilometers. So therefore, what is the actual distance travelled by the object? It is 80 kilometers. So therefore, the actual path travelled by an object, so from one place to another, so it is called as a distance travelled. Remember, distance travelled is a scalar quantity and it can be positive. Always it is positive and it can't be zero. And its SI unit is meter. Now, the next bit, that is displacement. So, what is displacement, children? The shortest distance between the initial position and the final position is called displacement. Here I have written displacement is a vector quantity. When I say vector quantity, so I need to consider the direction, that is east, west, north and south. And remember, the displacement can be positive, negative and also it can be zero. Its SI unit is meter. That means, so if I take example, the same example I'm going to take, say the object is at the position A. Now, what we will take is, so let me take the object will start moving from A to C. That is, it has moved from the position A to C. Okay. The same example I am telling children because you can easily understand it. So then, what will be the length of the shortest distance from the initial and the final position? Now it is 60 kilometers. Now again the object will move from C to B. So as it is moving from C to B, now the object is in which position? It is at the position B. According to our definition of displacement, the shortest distance between the initial and the final position. Here we are not worried about the actual path. Here we are mainly concentrating in the initial position and the final position. Where was the object earlier? At position A. And where is the object now? At position B. Then what is the shortest distance? So shortest distance is 0 to 40. So therefore, I can say the displacement is 40 kilometers. 40 kilometers. Okay. So since I have taken uh, the magnitude unit as kilometer, I can say 40 kilometer. Here, as I am moving, okay. So here I need to mention the direction. Yes, it is direction. When I say the object is moving from the point A reference point to C, then in which direction it is moving? If I take the position as north, south, east and west, then the from A to C it is moving in the east direction. Again, if from C to B it is moving in a west direction. So I can say the object is moving from point A to C in the east direction and from C to B in the west direction. Okay. So remember, so the shortest distance between the initial position and the final position gives the displacement. It can be positive, negative or zero. If I take a reference point, if the object is moving in the direction towards the, that is away from the reference point, it will be positive. If it is in the direction opposite to that of the motion, then it can be negative and it can be zero also. When will that displacement will be zero, children? So when I say 0 to C, how many kilometers it has traveled? 60. So instead of taking from C to B, if I take from C to A itself, okay, then earlier it has from A to C and then again from C to A. Earlier also the object was at A, now also the object is at A. Therefore, what is the shortest distance? So the shortest distance is 0 km. Let us recap the differences between the distance and displacement. As I said, distance is nothing but the actual path, length traveled by an object, and displacement is the shortest distance between the initial point and the final point. So the next differences is distance is a scalar quantity, that is it is having only magnitude, whereas displacement is a vector quantity having both magnitude and direction. So remember, distance traveled is always positive and it can't be zero. So whereas displacement can be positive, negative and it can be zero. So children, take down the homework for today's class. So first question is define motion and the second question is define the scalar and vector quantities with an example. Third question is differentiate between scalar and vector quantities. Thank you, children, for watching the class. I hope you have understood everything, and we will continue in next class about few more concepts.